Hello. We learned some basic properties of a binary distribution. What is the mean and what is the variance. And we are going to generalize the binary distribution to a binomial distribution, which is the title of this chapter. So how we compare them? A binary random variable x is the result from a single binary experiment. It is from a single binary experiment, which means there are only two possible outcomes, and there are either 0 or 1, success or failure. But now think of the case that the same experiment is repeated for a certain number of times. So then we have a binomial distribution. So binomial random variable y is defined as the number of successes in n number of binary experiments. So if the experiment is repeated n times, then you observe the outcomes and then you only count the number of successes. That is binomial random variable. And y can take integers, any integers between 0 and n. So 0 means there is no success from n number of experiments. And when the outcome is n, y equals to n, that means you succeeded in every experiment. So it cannot be smaller than 0, obviously, and cannot be greater than n, obviously. So that's how we define a binomial distribution. It is another parametric distribution family, and it requires a little more assumptions because its structure is more complicated. It requires 4 assumptions. First, there are n trials of binary experiments, so n times, and 2 possible outcomes from each trial. Obvious, each of them is binary. And the probability of success is p for all trials. So the probability of success does not change over the repetitions. And finally, the trials are statistically independent. Do you remember how we defined statistical independence? We defined this in chapter 2. In chapter 2, when we learned like conditional probability and multiplication rule, and then statistical independence was defined, and it is really important. So we are going to think about this later again. And if you don't remember what it is, please go back and remind yourself of what's the definition. Just look up the slide or watch the video. And also, like this, the results from the previous chapters will be used later. That's how I designed this course, and you will see this kind of old concepts will come up again in the future. What you learn today will be used at some point later. So, and I think it's pretty easy to go back review the past, like in this online teaching setup, online learning setup. So I think that's the most powerful advantage of online teaching. So I want you to make use of this advantage. Okay, anyhow, there are 4 assumptions. Then if these 4 assumptions are satisfied, then we write the binomial random variable y follows a binomial parameter n, p. So the name of the distribution is binomial distribution family with 2 parameters. Now you need 2 parameters, n and p. And as you see, n is the number of repetitions and p is the probability of success. You have to know these 2 guys. And then y captures the distribution for the number of successes from the repetitions. And let's think about the previous example of randomly choosing homework answers. So if you answer one random answer to one question, the outcome is yes or like correct or wrong. It's simply correct or wrong. If you are correct, you get 1 point. If you are wrong, you get nothing. That was our example in the binary distribution. But now you can extend the same example to multiple questions. And suppose that if we don't have any exam, but suppose that there was an exam like in a homework. Think about homework. In a homework, there are 10 questions, and each question has 5 choices, and only one of them is correct. Then, if you randomize all 10 answers, you have no idea what's going on, and simply randomly choose the answers. You can do the experiment by yourself, and and the result is your grade. Grade from that homework is the number of correct answers. Or you can think it as if you choose a correct answer, you get 1 point. There is no difference. Number of correct answers or 1 point for each question. And the grade will be the same. So you can define y as the sum or the number of correct answers. They are the same thing. And the possible grades from the homework is n minimum 0 if you are super unlucky. And at most, if you are super lucky, you can get the maximum possible grade. And then in this case, we can say that y is a binomial random variable with parameter 10 and 0.2. N equals 10, p equals 0.2, right? This is an example, maybe simplest possible example we can think of, and as for the binomial distribution. Okay, now what we are going to do here is we are going to derive what is the probability for a binomial distribution and what is the mean, what is the variance. These 3 basic measures will be studied, examined in the binomial distribution case, and it takes much more complicated steps than you can imagine, maybe. So let me try. I will try this. Maybe it takes like one whole lecture, I guess. So I'm going to start now, but we will get to the conclusion in the next lecture. So don't be disappointed if it's too easy now. It will get very complicated pretty soon. So I will think about another example to show you the derivation steps. We will consider reservations and cancellations. Think about you are a manager of a flight. Say you work for an airline company and you handle reservations and cancellations. And suppose that for a flight you accepted 10 reservations, right? 10 reservations were made for a flight. And suppose that probability of cancellation for each reservation is 10%. So a single reservation may be cancelled with 10%. And I will additionally assume that 10 reservations are statistically independent, right? That means the cancellation of the first ticket has no effect on the cancellation of the others, right? If, for example, if the first 2 passengers are a party, then the independence is a little bit unrealistic. But I assume that the 10 reservations are made by 10 different parties, and they do not know each other, and they don't care what others, whether others cancel or not. So they do not have any effect with each other. And I am going to define xi, random variable xi, as the cancellation of reservation, cancellation status. it is defined as the cancellation status. So it takes 1 if the reservation I, subscript I, is cancelled. So 1 means cancellation. So as I said, 1 and 0 are value neutral. I don't make any judgment. So even if cancellation is not good for you, but I'm going to call it success because we are learning statistics. And statistically, I don't care if cancellation is good or bad. Anyhow, we promised to write 1 if it's cancelled and 0 if not cancelled. And then y is the total number of cancellations out of these 10 reservations, right? So there are 10 reservations and y is the number of cancellations. Then it follows if these assumptions are satisfied, this y variable follows a binomial distribution with parameter n and p. And those parameters are known 10 reservations because a single reservation, one reservation is one experiment because probability is attached for each reservation and it is repeated 10 times. So n is 10 and p, probability of success, and success in here is cancellation. That's how we defined. Cancellation is success, so its probability is 10% again. So this is how we define a binomial distribution. And then I will ask you a question. It's a brain teaser. There are 10 reservations. Probability of cancellation is 10%. It's pretty simple. And all cancellations are statistically independent. We learned the number of cancellations is a binomial distribution. And then we need to know the binomial distribution to answer this kind of question. For example, what is the probability that exactly 2 reservations are canceled? Out of 10, we are interested in the probability that 2 of them are canceled, but the other 8 tickets are not canceled. What is that probability? Yes, at this point, I think you cannot answer this, but our goal of this lecture and the next lecture will be to answer this question. I'm going to finish this video here and I will keep going in the next one.